So good day everyone. For our today's discussion, we will talk about the tidal energy. So before we start, pag-usapan muna natin kung ano nga ba yung energy sources. So yung energy sources, importante siya sa ating mga tao in our daily lives. Yung energy sources, meron dalawang types, which are the renewable and non-renewable energy resources. So yung non-renewable, meron lang tayong limited quantity, kaya hindi natin siya napoproduce ng gano'ng kabilis. While yung renewable energy, ito yung natural na nagre-replenish over time. Yung examples ng non-renewable energy, ito yung coal, fuel, gas, etc. While yung renewable energy, ito yung, ang examples nito ay yung wind energy, solar energy, geothermal energy, and etc. Let's now proceed with our topic for today, which is all about the tidal energy. So what is tidal energy? The tidal power or tidal energy is harnessed by converting energy from tides into useful forms of power, mainly electricity using various methods. So yung tidal energy, pwede rin siya sa tawag na ocean energy or yung tidal power. Tandaan natin na yung tidal energy, ito yung nagko-convert ng energy na galing sa tides into a form of power, such as electricity. So what is a tide? Tidal energy is created using the movement of our tides and oceans, where the intensity of the water from the rise and fall of tides is a form of kinetic energy. Tidal power surrounds gravitational hydropower, which uses the movement of water to push a turbine to generate electricity. So dito makikita natin na yung meaning ng tide, ito yung pag-rise and pag-fall ng tubig. What causes tides? High and low tides are caused by the moon. The moon's gravitational pull generates something called the tidal force. The tidal force causes Earth and its water to bulge out on the side closest to the moon and the side farthest from the moon. These bulges of water are high tides. Most coastal areas, with some exceptions, experience two high tides and two low tides every lunar day. Unlike a solar day, however, a lunar day is 24 hours and 50 minutes. So sinasabi dito na yung tides ay kadalasang nangyayari sa ating coastal areas. Tapos, in a lunar day, we experience two high tides and two low tides. Ang kaibahan nun sa solar day, yung solar day kasi meron lang 24 hours. While yung lunar day, meron siyang 24 hours and 50 minutes. So, bakit may 50 minutes? Yung 50 minutes na to, merong 50 minutes kasi gumagalaw yung buwan, tapos umiikot sa atin, sa Earth. So, meron din nagsabi na sa isang research na yung moon ba ay pwedeng makaapekto sa tao. So, merong research na gumagaan daw yung tao ng microgram lang naman kapag nagkakaroon ng tides. Tsaka pwede siya pwede magkaroon ng change sa attitude or behavior ng isang tao. Pero sobrang minimal lang. So, ayun. Proceed na tayo ulit. Because the Earth rotates through two tidal bulges every lunar day, coastal areas experience two high and two low tides every 24 hours and 50 minutes. High tides occur 12 hours and 25 minutes apart. It takes 6 hours and 12.5 minutes for the water at the shore to go from high to low or from low to high. So, kailan daw nagkaka-high tide and low tide? Sinasabi dito na nagkakaroon tayo ng high tide um, every 12 hours and 20 minutes apart. Tapos, it takes 6 hours and 12.5 minutes para yung tubig ay mapunta sa high to low and low to high. So, makikita natin dito yung animated illustration kung kailan nagkakaroon ng high tide at low tide. So, mapapansin nyo dito na kapag nakatapat siya, yung Earth sa Moon, nagkakaroon ng high tide. And kapag nasa opposite direction din, yung Earth, nagkakaroon din ng high tide. While naman, mapapansin nyo, kapag nakagilid or nasa sideways, nagkakaroon siya ng low tide. Makikita rin natin dito sa picture na to na meron tayong dalawang low tide at saka dalawang high tide, which are the high tide and low high tide. If high tides are caused by the gravitational pull of the moon on Earth, why there would be high tides on the side of the Earth opposite the moon? So, sinasabi dito na bakit nagkakaroon pa rin ng high tides kahit yung Earth ay nasa opposite side na ng moon. The high tide on the side of Earth facing the moon is called the high tide. The high tide caused by the bulge on the opposite side of Earth is called the low high tide. So, di ba sabi ko kanina, meron tayong dalawang high tides and dalawang low tides. And yung dalawang high tides na to, ito yung high tide, ito yung low high tide. So, kapag daw nakaharap yung direction sa moon, ito yung tinatawag na high tide. While kapag nasa opposite direction naman, ito yung tinatawag na low high tide. A low high tide may be understood as the moon's tidal force pulling the planet, not the ocean toward it. Ito, in-explain dito na yung kung ano nangyayari on the side facing the moon. The gravitational attraction between the Earth and the moon is strongest on the side of the Earth that happens to be facing the moon, simply because it is closer. This attraction causes the water on this near side of Earth to be pulled toward the moon. As gravitational force acts to draw the water closer to the moon, inertia attempts to keep the water in place. But the gravitational force exceeds it and the water is pulled toward the moon, causing a bulge of water on the near side toward the moon. So, sinasabi dito na kapag naka-face yung side na yon sa moon, malakas yung gravitational pull kasi mas malapit sa moon. Tapos yung inertia, siya yung force na nagki-keep intact dun sa may water. Pero yung gravitational force ay mas malakas kasi mas malapit siya sa moon. Kaya nagkakaroon siya ng bulging ng water. So, dito naman, on the side opposite the moon, on the opposite side of Earth or the far side, the gravitational attraction of the moon is less because it is farther away. Here, inertia exceeds the gravitational force, and the water tries to keep going in a straight line moving away from the Earth, also forming a bulge. Gravity and inertia act in opposition on the Earth's oceans, creating tidal bulges on opposite sides of the planet. On the near side of the Earth, the side facing the moon, the gravitational force of the moon pulls the ocean's waters toward it, creating one bulge. On the far side of the Earth, inertia dominates, creating a second bulge. So, sinasabi dito, so ito, makikita natin sa picture na to. Ito yung side na naka-face sa moon at ito yung side na opposite direction sa moon. So, yung bulge dito, yung tidal bulge daw na nangyayari sa side na nakaharap sa moon ay dahil sa gravity. Dahil mas malakas yung gravitational pull doon kesa dun sa inertia. While dito naman, sa may opposite side ng moon, yung tidal bulge niya ay dahil sa inertia. So ang pinaka-reason dito ay yung planet, kapag ito ay yung sa opposite side ng moon, yung planet yung pinupul ng gravity. Yung water nagmo-move away sa Earth, kaya nagkakaroon siya ng bulging. Kaya kahit nasa malayo siya or nasa opposite side siya ng moon, nagkakaroon siya ng bulging of water. Kasi nga, dinodominate siya ng inertia. Bale, kapag nasa opposite side ng moon, yung gravity tsaka yung inertia, nag-a-act siya oppositely. Kaya, nagpo-form pa rin siya ng bulge. So dito, meron tayong table dito na nakalagay yung largest tidal power stations as of May 5, 2021. So meron tayo ditong 5 stations. Kasama na rin dito, naka-indicate na rin dito yung capacity niya in megawatts, tsaka kung saan siya located at kung kailan natapos. So yung first station natin dito is yung Siwa Lake Tidal Power Station. Meron siyang capacity na 254 megawatts at matatagpuan siya sa South Korea. So natapos yung power station na to noong 2011. While yung second largest naman na tidal power station is yung Rance Tidal Power Station na may capacity na 240 megawatts na matatagpuan sa France. So makikita natin dito na siya yung parang pinaka-una dito na natapos or nagawa. Kasi 1966 pa lang ay nakatayo na siya. So next is the Annapolis Royal Generating Station na may 20 megawatts capacity na matatagpuan natin sa Canada at naitayo noong 1984. The fourth one is the Maygen, which has the capacity of 6 megawatts, located in the United Kingdom and built in 2017. And the last one is the Liangsha Tidal Power Station na may 3.2 megawatts capacity na matatagpuan sa China. Tapos, nagawa siya noong 1980. So, itong 5 na tong station, makikita niyo siya, nakasunod-sunod siya in chronological order. Kung ano yung maximum capacity na kaya niyang i-handle at i-produce. So, makikita nyo rito sa table na to na yung tidal energy pala is matagal na palang nage-generate. Kasi tingnan mo, 1966 pa lang, meron na. So, meron tayong 3 types ng tidal power, which are the tidal stream generator, tidal barrage, and the tidal lagoon.
So, types of tidal power. Tidal stream generator. So, ano nga ba ang tidal stream generator? The tidal stream generator are very similar to wind turbines, except they are below the water surface instead of above or on land. So, the water's current pushes the blades of the turbine, which is connected to a generator that creates electricity. So sabi dito, nagkikreate ng electricity ang isang tidal stream generator through the water current na nagtutulak sa blades ng mga turbine. At ang mga blades ng mga turbine na ito ay konektado sa generator na nagkikreate ng electricity. So sabi pa dito, the tidal stream generator are able to produce much more electricity than wind power plants. So bakit nga ba? Because of the water is much denser than air. However, water's high density also means that the tidal turbines need to be much stronger than the wind turbines, making them more expensive to manufacture. So sabi dito, dahil ang water nga daw ay much denser than air, so nangangailangan na ang isang tidal turbines ay much stronger than the wind turbines. But nagkakos naman ito ng more expensive to manufacture. Pero ang kapalit naman nito, nakakapag-produce ito ng mas mataas na electricity compare sa mga wind power plants. Sabi pa dito, the tidal stream generator turbines are large, but they create relatively little disruption to the ecosystem around them as compared to tidal barrage. So the world's first tidal stream generator was constructed in 2007 at Scranford Lough in Northern Ireland. So, tidal stream generator. So, sa tidal stream generator, makikita dito ang tidal stream, mga parts ng isang tidal stream generator na concrete block, tripod, na siyang nagbibigay foundation sa isang tidal stream generator. So sabi sa description kanina, through the water current that pushes the blade of the turbines and the turbines that connected to the generator that makes electricity. So next is the tidal stream generator. Ito pa ay isang 3D example ng isang tidal stream generator. So types of turbine used in tidal stream generators. The first one is HOUT or horizontal axis wind turbine. It's also known as axial flow turbine. So sa type ng ganitong turbine, ang rotor nito ay parallel axis to the tidal currents, while the bout or vertical axis wind turbine, ito ay may rotor na ang axis ay normal to the tidal currents. So this is image of the Siegen tidal stream generator, Strangford Lough.
Good day, I'm Victor Tidal and I'm here to discuss about tidal barrage and tidal lagoon. The first one we have here is the tidal barrage. What is tidal barrage? Tidal barrage are low-walled dams usually installed at tidal inlets or estuaries. Similar to traditional hydroelectric dams, sluice gates are used to create a reservoir on the one side of the barrage. The barrage is secured to the seafloor while the top of the barrage is just slightly above when the water level hits during the highest tide. Tidal turbines are located towards the bottom of the barrage, inside a tunnel which allow the water to flow through. Tidal barrage look like a traditional hydropower dams. Turbines located along the bottom of the barrage are turned with the incoming and outgoing tides. During an incoming high tide, water flows over the turbines as the water rises. Then the water flows back through the turbine as it becomes low tide. The turbines are connected to a generator which produces the electricity. After a construction phase lasting 5 years, the Brans Tidal Power Station was opened on the 26th of December 1966. This was the first power station to take advantage of tidal water flow to produce electricity. This is the photo of bronze tidal power barrage. This can be located at France. This one is the Siwa Lake Tidal Power Station located in South Korea. And this is the tidal barrage illustration. We can see how the tidal barrage works. Itong side na may word na low tide is the seaside. And this side na may tidal basin is the bay side. Kapag mas higher yung seaside, dapat mag-open yung sluice gate and magpo-flow yung tides papunta sa bay side. And yung tide na yun magko-cause na umikot yung turbine generator na magpo-produce ng electricity. Dapat mas mataas yung tide ng seaside ng 2 meters para magbukas yung sluice gate at makapag-produce ng electricity. Ito naman yung kabaliktaran niya. Kapag mas mataas naman dito sa may bay side, dito naman magpo-flow yung tide papunta doon sa sea. And magkukos din yun ng pag-ikot ng turbine na magpo-produce ng electricity. Para mas malinaw, may video dito.
Hi, John here. Today I'm going to do a short video about tidal power generation, and I'm going to try and do it in about a minute. We'll play the animation now. You can see the tide coming in on the left-hand side. This represents the ocean on the left and a bay or an estuary on the right. We've used a concrete structure in the middle to block the flow of the tide going into the bay or the estuary area. So the tide's building up, it's going to keep rising on the left-hand side, but nothing's happening on the right. Once we've got at least 2 meters in height difference between the bay and the sea area, we're then going to open a wicket gate or sluice gates, and we're going to allow flow from the sea area to the bay area. We need at least 2 meters difference in head in order that we get sufficient flow. The water goes into a draft tube, flows over a bulb turbine, and causes the propeller to turn. The propeller is connected to a propeller shaft and a generator, and the generator turns and generates electricity. So we're now generating electricity just due to the flow of water through the draft tube. We're filling up the bay area, we're maintaining a minimum of 2 meters difference in head between the two sides, and we're going to fill up the entire bay. At some point we lose this 2 meters difference in head and we stop generating electricity because there's not enough flow. So we'll fill up the bay to the same level as the maximum tide. You can see now that's leveled out, and we're going to do the exact opposite. Now we're going to close off the barrage again. We're going to let the sea level recede until there's at least 2 meters difference in height again between the two, and then we're going to open up the sluice gates or the wicket gates. We're going to generate electricity this time by adjusting the angle of the propeller blades slightly. As water drains out of the bay area at roughly the same speed as the tide is receding, we're going to continue to generate electricity, and that is essentially how tidal power generation works.
And according sa video, kapag pantay yung tides ng dalawang side, hindi mag-open yung sluice gate, meaning nun walang mapoproduce na electricity. The next one is about tidal lagoon. What is tidal lagoon? A new tidal energy design option is construct a circular retaining walls embedded with turbines that can capture the potential energy of tides. The created reservoirs are similar to those of tidal barrage, except that location is artificial and does not contain a pre-existing ecosystem. The cancelled tidal lagoons and Swansea Bays in Wales, United Kingdom would have been the first tidal power station of this type once built. Ayan, ito yung tidal lagoon at tidal barrage. Ano yung pagkakaiba sa kanilang dalawa? Yung tidal barrage is a dam-like structure, para siyang dam. At yung tidal lagoon naman is a power station. Ang pagkakaparehas nila, parehas sila nagre-rely sa sa tides. Sa high tides, low tides, sa tides. Doon sila nagre-rely para makapag-produce ng electricity. At yun lang ang aking. And that's all. Thank you.
Good day, this is Francois Campana and I'm going to discuss the advantages and disadvantages of tidal energy. So, unang advantage ng tidal energy ay yung renewable. Tidal energy is a renewable source of energy, which means the energy doesn't deplete as it is used. Siyempre, yung gagamitin mong fuel and para mapaikot yung turbine ay hindi na uubos, nandiyan lang siya. Next advantage of tidal energy ay yung zero carbon emission. In addition to being a renewable energy source, tidal power stations do not emit greenhouse gases during electricity generation. So, zero carbon emissions, hindi siya nakaka-harm sa environment at sa mga tao. Sunod na advantage ng tidal energy ay yung predictable. Tidal currents are highly predictable. Low and high tides follow well-known cycles, making it easier to know when power will be produced throughout the day. Yung tubig kasi, very predictable. Halimbawa, sa ganitong oras, high tide, sa ganitong oras, low tide. Kaya alam nila kung kailan gagana yung power plant or kailan mamatay. Yan. Next advantage of tidal energy is high power output. Tidal power plants are able to produce high amounts of electricity. One of the main reasons for this is because water is so dense, almost 800 times more dense than air. As compare sa air or sa wind turbine, mas malakas yung power output or energy na napoproduce niya. Yun ang mga advantages ng tidal energy. Next is disadvantages. Disadvantages of tidal energy ay yung limited installation sites. Limited lang siya, nakalocate lang siya sa mga coastlines. In order for tidal power plant to be built, the potential installation site must meet very specific requirements. First, they need to be located on a coastline, which limits potential station sites to coastal states. There are additional requirements a potential site must meet. For example, tidal power station need to build in places where the difference in height between high and low tide is significant enough to power turbines. This limits where the power station can be installed, making it difficult for tidal power to be implemented widely. Next disadvantage of tidal energy ay yung expensive. Sobrang mahal nito. One of the biggest drawbacks to tidal power is the high upfront costs. Tidal energy turbines need to be much sturdier than wind turbines because of high density of water. Most of the tidal power plants that are currently in operation are made of tidal barrages. The construction of tidal barrage is extremely expensive. Sobrang mahal daw niya. Ito na nga yung Daron's power plant. Ayan. Daron's power plant. Sobrang mahal daw na pinagawa niya na umabot ng 20 years bago niya mabayaran. Ayan. Sobrang mahal yun. Yung pagpapagawa ng tidal energy. So, next disadvantage of tidal energy ay yung environmental effects. Ayun na nga. Nakakasira siya ng marine ecosystem. Tidal barrages disrupt the natural flow of water in and out of estuaries. This can have an effect on marine life, disrupting life cycles and spawning. Underwater turbines have the potential to kill marine life, much like wind turbines kill birds. This concern is valid amongst all tidal power plants, but larger marine life is likely to only be affected by tidal stream generators. In runs, since the tidal barrage construction needed to drain the estuary in the initial years after construction was completed, there were severe impacts to the local environment. However, 10 years later, it was considered that the Rance estuary once again had a rich diversity of aquatic life. Tidal energy, it really disrupts marine environment. Naging apekto nito yung pag-iiba ng water, namamatay yung mga marine lives. Pero ngayon, sa dami na ng technology, nagagawa na nila ng paraan para maiwasan masira yung marine ecosystem. Nami-mitigate na nila. At yun po yung advantage and disadvantage of tidal energy.
The future of tidal energy. So sabi dito, the tidal energy has the potential to offer all the power we need that eliminate the need for fossil fuels. So stated by CIMEC Atlantis Energy that the tides move a huge amount of water twice a day. Harnessing it could provide a great deal of energy, around 20% of Britain's need. So malaking porsyento na ito na kaya mo-provide para sa ating need sa energy. So sabi ba dito, the British companies and universities are currently developing a new wave of technology, supported by grant from the 50 million euro Marine Renewable Deployment Fund. So almost 10 years ago, the Southwest Regional Development Agency installed the Wade Hub technologies. The most technology sophisticated open access site for testing outdoor renewable technologies 16 km off the Cornwall coast. So meron pang ibang company na also making a splash in the United Kingdom. So ito ang European Marine Energy Center or EMEC in Courtney. So sabi nga dito na ang tidal energy ay may potential na mag-provide ng power na kinakailangan natin kung madedevelop pa ito sa future. At dahil dito, pwede nating ma-eliminate or mabawasan ang need natin or ang paggamit natin sa fossil fuel na ginagamit natin para mag-provide ng energy source.
So before we end our today's discussion, here's a short summary about the tidal energy. So yung tidal energy is one of the examples of renewable energy sources. Yung tidal energy, ito yung pag-convert ng power from tides. Yung tides naman, ito yung pag-fall and pag-rise ng tubig. At yung tides, at ang nagkukos ng tides ay yung buwan. So sa isang lunar day, nagkakaroon tayo ng 2 low tides and 2 high tides. So we have 3 types of tidal power. And these are the tidal stream generator, tidal barrage, and the tidal lagoon. The advantages of tidal energy are it is renewable, it is zero carbon emissions, predictable, has high power output, while the disadvantages of tidal energy are it only has limited installation sites, expensive, and lastly, it has environmental effects. So, I'm Precious Gem R. Hernandez, and my group members are Francois Campana, Victor Lorenzana, and Nico Carlinas. Thank you for listening.